Brought to you by Connect.js, Atlanta's premier JavaScript conference. Sponsored in part by FeatherDirect. Need a mobile app? Contact us for your custom mobile solution.
Okay, I think we're going to get started if you guys are ready. So I'm going to start by being annoying and ask all of you to stand up, please. Stand up. I promise I won't make you turn and introduce yourself to your neighbor or anything like that. Stay standing if you love JavaScript. Okay, cool, that was a test. Stay standing if you have some background or some experience with functional programming of some kind. Functional programming, okay, great, and stay standing if you have some experience with functional reactive and this whole kind of FRP paradigm. Okay, good. All right, so I'm going to talk to you guys today about functional reactive JavaScript, and this is kind of the paradigm of functional reactive programming brought to JavaScript, obviously. So functional reactive programming is a pretty big topic. Fundamentally, it represents a different model of computation in our software. So that's a pretty big deal, right? That sounds quite intense. One of the biggest differences with FRP is how we think about and model state in our program. So data, values, state in our program. With FRP, we model values differently. We use a different model to represent relationships between values. And we use a different model, slightly different model, to represent how those values change over the course of time as our program executes. So I'm going to go into a little bit more detail about all of that as we go along, and hopefully we'll leave the talk feeling like that was a little less hand-wavy than we are right now. A little bit about me. My name is Pete Hodgson. As you can tell from my accent, I'm based in San Francisco, and I work for a company called ThoughtWorks. We're a custom software delivery consultancy, so we help our clients build awesome software and get better at the process of building software. If you want to know more about ThoughtWorks, come find me or go to the ThoughtWorks booth because we're a sponsor. And we get to choose our own job titles, which is nice. Okay, so I said that with FRP we represent values differently. So what do I mean by that? So in a standard program, we tend to represent values using variables. And if you think about it, a variable represents a snapshot of a value at a specific time. So if I want to know the current contents of the text field in a UI, I might call a method and get back some string, and I'll put that string in a variable. At the point in time that I called that method, that variable represents the contents of that text field. If the contents of that text field now changes, that variable does not represent the current context of that text field. So that's what I mean by it's kind of a snapshot. A variable doesn't keep up to date with reality. And this is something that we've probably internalized a little bit. It just seems kind of like, well, duh. But actually, I don't think it needs to be that way. And FRP kind of introduces this alternative model where we think about values in terms of streams. The difference between a variable and a stream is a stream represents not just the current state of something, but also all future states of that thing. So if I ask for the stream representing the contents of a text field, for example, what I'm going to get back is not just the current contents of that text field, but something that will always represent, even in the future, the current contents of the text field. So it will keep up to date. It's not a snapshot. It's a living thing that evolves as our program moves. So how do we use these streams? I'm going to talk about them today in the context of UI development. And in the context of UI development, we have three big ideas. So first of all, we have UI elements which produce streams of values. So as I said, you can kind of imagine asking a text field for a stream representing the current contents of the text field. We also have functions which can combine and transform these streams into new streams. So we can take these values and we can do things with them. And finally, we have the ability to assign a stream to some UI attribute so that you can kind of produce some output in your program. Now, if you think about it, this is really, these three things is the core to any kind of UI development, not just functional, reactive, whatever. Anytime you're doing UI development, you are reading input from the user, reacting to the user interacting with your program. You're performing some computation. You're kind of doing the business logic, thinking about things and adding stuff up or whatever. And then finally, you're producing some output. You're writing something back to the UI because it would be a very boring computer program if it didn't actually change ever, right? So these three ideas we use all the time. These three concepts are in every UI program. This is just how streams and FRP work in the context of these three big ideas. So for the rest of the talk, I'm going to kind of try and show you what I mean by this with some live examples. You can see I'm rolling up my sleeves. We're going to build some UIs in JavaScript. We're going to use this incredibly hipster-looking framework called Bacon.js. I have no idea why it's called Bacon.js. I have no idea why he's wearing sunglasses. I think he probably lives in San Francisco. He looks like a hipster to me. Okay, so let's get started. If my computer behaves. So our first example, we have a slider here in the middle. And we have this label over here. And what we're going to do is we're just going to do some really basic kind of data binding. We're going to assign the, we're going to update that label so that whenever we change the slider, the current value of that slider is going to be assigned to our output label. So I've kind of cheated a little bit, and I've kind of made the shell of a program here, just basic jQuery stuff. You should be fairly familiar with it if you've used jQuery before. And the first thing I'm going to do is I'm going to ask for a stream. So I'm going to say, let's say the values coming off the slider is the slider as event stream. And specifically, I want the input events. So what's happening here is I'm using the one method that Bacon adds to jQuery. Bacon has a tiny little jQuery plugin that means for any jQuery object, I can ask for an event stream for that object. So I've asked Bacon to give me the event stream of all input events for this slider. And I can see whether that looks right by logging it out. And so now I have this values thing here is a stream, and I can ask that stream to log. So now if I go over and reload my page and pop open the DevTools and go to the console, what I should see, yeah. So every time I move the slider, I get a new event popping into this event stream. And you can see that because I've got a log. So every time a new event comes through this event stream, I've got a new, it's logged in console.log over there. So right now, what I've got is a raw jQuery event. And that's helpful, but it's also not really what I care about. Really, I care about the current value of the slider. So the first thing I'm going to do is turn this stream of raw jQuery events into a stream of values representing the current value of the slider. And I've cheated and added a little function up at the top of the file here called input event to val, and I'm going to give that to Bacon. I'm basically going to say to Bacon, hey, when you build this stream for me, the first thing I want you to do every time there's a new event is use this function to turn it from a raw jQuery event into, well, you can see there on line 7, into the value of the thing that is firing the event. And so now, hopefully, when I log this guy out, much more exciting stream of events here. We've got the raw values coming off of this piece of UI. So console.log is nice. What would be nicer is some kind of visualization. So let's say visualize. And so I've called this visualize method on my stream. And now every time, let's move this guy over here a little bit. Now every time a new event appears on the stream, we can actually see the events flowing through the stream. So you can see every time the slider moves, a new event appears. And you can also see on the right there's the current value of this stream. So whenever the stream changes, new values appear. We always have the current value available to us. So now we've got this stream of values. Let's assign it to this label. I can say values, assign, and I want to assign it to the label that I predefined, and specifically I want to assign it to the text attribute of this label. Now that I've done that, as if by magic, we have some basic data binding going on. So that last piece, what I did here on line, whatever this line is on line 12, is I said to Bacon, hey, whenever a new value appears in this stream, call the text method on the label object. That's what this is doing. So what's important to note here is there's nothing jQuery specific going on with this assign. I could call any method on any object. I happen to be interested in essentially doing this. I essentially want to call text, which is a method that jQuery gives us, and kind of fill in the blank with whatever the current value of the field is. So that's what's happening under the covers. But you can imagine this isn't specific to jQuery. This isn't specific to UI. This is a general purpose technique that I could use for any type of JavaScript programming, not just UI programming. So we have our basic data binding going on. Questions so far about this? What's confusing about this code so far? It's so clear that no one has any questions at all? Good, okay, I guess we'll move on. So that's great, we've got basic data binding. Let's do something more interesting. Now what I would like to do is, rather than representing the raw value of that slider, I want to do some formatting. So rather than it being a value from 0 to 1 in the label, I want it to be a percentage. So I would like to change this to be 48% on the label. And specifically, actually I want to do some rounding, and I want to round it up to 49%, not 48. So let's start doing that. So the first thing we're going to do is we're going to create a new stream called, something that you may have noticed, the eagle-eyed amongst of you may have noticed that this is in fact not a floating point number coming off of this stream. This is a string. This is because jQuery, when it fires events, it's firing events. The value of those events is a string, not a number. So the first thing we need to do is turn this into a floating point number so that we can work with it. So let's say floats are going to be values mapped through a function. And in this case, we want to parse that function, or parse that value rather, and turn it into a float. And let's see what that looks like. So again, we've got our visualize method. And so hopefully now, you can see, if you squint, that these are numbers, not strings. So we've got our first kind of piece of transformation going on, that second piece of those three big ideas I started with. So this is a very core part of the principle of FRP, is this concept of transforming values. And again, it's a very general tool. So I can give to Bacon any function which takes an input and returns an output, and I can use that function to transform any stream. So any stream that has something flowing through it, I can kind of put a pipe next to it and do some transformation. And I can keep chaining these things together. So I'm going to keep chaining them together, and I'm going to turn this into a percentage. Percent is going to be the float. Let me move this guy up here. Mapped through a second function. And this guy, we want to, well, what do we want to do to turn it into percent? We want to times it by 100, and then I said I wanted to do some rounding, so I'll do some rounding. And let's visualize that guy. And now we're running out of screen real estate, but you can see I've got 32 here, so I'm actually rounding it to the nearest value, and you can trust me that it rounds up and down correctly. So that's great, we're almost there. Let's do some formatting. I want to put a percent sign at the end. So let's say var formatted is the percent mapped through yet another function. And this, I'm going to write some ugly JavaScript because it's JavaScript. Oh, and I need to remember to return this. And now I've got my formatted stream. So this stream is going to have the formatted results. And then I could visualize this, but actually this is the thing I actually want to assign to my label. So I'm just going to say assign it to the label, to the text part of the label. And so hopefully, if I did everything correctly, hooray, we've achieved our goal, and we have now like a nice formatted value. So hopefully this gets across how easy it is to kind of compose these things together. And I've been quite verbose in this code. I've been kind of creating a bunch of intermediary variables, and I've been doing visualization as I go through. You can imagine that just like with jQuery, you end up chaining a bunch of these methods together. You can do the same thing with Bacon. So I could take all these and turn them into quite terse piece of JavaScript code that represents just the logic in my program. So what's really important here is I'm being really declarative about what I want my code to do. I'm saying I take these values, I pass them through these transformation functions, and they end up on this label. I don't have to do any of the plumbing or keep track of anything myself. Bacon does all that stuff for me. I just declaratively say at the start of the program, I want this to be the case, and it becomes the case. I don't have to do any manual work to keep up to date with that. Questions about this code so far? Anything that's not clear? Yes?
So when you're rounding that, let's say you have a number, it's currently at 0.101, and you move it from 0.101 to 0.102. After you multiply by 100 rounds, you're going to get 10% both times. Does it deduplicate those events, or are you actually getting multiple events fired for each of those?
Okay, great idea. I'm going to repeat that just in case people didn't. So basically, if you have multiple events that look the same, do they get deduplicated, or are they going to have multiple events in that stream? So the answer is, by default, there will be multiple events flowing through that stream. Now, if for this program we wanted to remove them, there's a function I believe is actually built into Bacon that will dedupe things. And it's a really good question, actually, because it highlights the power of FRP is how general this solution is. We're not writing a solution for deduping events in a jQuery event stream. We're writing a solution, someone else has written for us, in fact, a solution for deduping values in a stream. And we can use that exact same piece of JavaScript to dedupe responses coming back from a network call. We can use the same exact piece of JavaScript to dedupe requests that we're making to an external server just as easily as we can deduping events from jQuery. So that like highlights one of the real values of this is it's a very general purpose solution. It's not about UIs. We're using it for UIs, but it applies more generally. Does that answer your question? Yeah.
Yes, thank you.
Other questions before we move on? Okay. So that was example number one. Let's have a look at another example. So now we want to get a little bit more complicated. Now we have two different sliders, and what I want to do is I want to bind the values of these sliders to these labels over here so we can see what the values are. But I also want to do some math. So what I want to do is I want to take the current value of each of those sliders and add it up to give me an outputted number. So if the first slide's at 2 and the second one's at 3, I want the output to be 5, and I wanted to show that in this label here. So we'll get started. So again, I've cheated a little bit and predefined these things because I can never remember how to use CSS. And we'll create our first stream. So stream A, values at A is going to be, and we're using the same techniques here that we used before. So slider A as event stream, and we want the inputs, and we want to pass it through our little helper function up there so that we get the raw values. And we're going to do the same thing for slider B. And so now we have our two values, and let's just go ahead and output those. And do the same thing for B. And so now you can see we're getting started here, and we've got the basics kind of set up. Let's assign these to the label so we can see what's happening. So out values A is going to be assigned to label A, the text property of label A. And we want to do the same thing for value B. And so now we're back to kind of where we started on the previous example. We've got some basic kind of data binding going on. So that's nice. But really what we want to work on here is combining these values. So let's see how we can combine these two streams, the stream that has 4 and the stream that has 7. Let's combine those two streams into a combined stream that's going to represent the values, or the summed values. So let's make a stream called combined, and we're going to use a property or a method that Bacon has called combine with. And what we're going to do is we're going to say to Bacon, I would like to combine stream A and stream B using some function. And again, this is very general purpose, so I can just give it any function I want. So I'm going to create a function in a second called summer. And here's stream A, here's stream B. So that's the Bacon side of things. Now I need to actually define what summer does, so let's define it up here. It's a function which takes 2 arguments and returns the sum of those 2 arguments. Pretty straightforward stuff. This encapsulates exactly like the business logic you could say is on this one line. And so what I'm going to have now is a combined stream, which I can now visualize. Combined, let's call it. And now whenever I change these sliders, ooh, I have a bug. Where is my bug? Anyone know where my bug is? Oh yeah, good. So you found the bug that I haven't talked about yet, but I'm also wondering why it's complaining about this guy over here. This is the joys of live coding, everybody. Stream A is not defined. Oh, values A, thank you. Thank you. Values A, values B. And yes, as you guys all already noted, you found my trap. Hooray for JavaScript. That's exactly what I wanted to do, was for it to concatenate. Well, let's zoom this out a bit. So JavaScript is helpfully adding together these 2 numbers, 7 and 3, to give me 73. Clearly my intent. Thank you, JavaScript. So yeah, so what's happening here is these are 2 strings. So JavaScript is saying, oh yeah, the string 7 plus the string 3 is obviously the string 73. Duh. Easy. Makes a lot of sense. So I need to parse these guys into floats, just like I did in the previous example. I didn't do it this time. So what I could do here is I could just kind of tack that parsing logic onto this line here, and then the same onto this line here. But this is starting to look like very copy-pasta, right? Like I've got almost exact same code on 2 separate lines. So let's dry it up a little bit. Let's write a little helper function. So let's write a function that gives us floats from sliders. And that's going to take a slider, and it's going to return basically this code here. So it's going to return the slider as event stream, and then I want to do the parsing, so I'm going to map it through the parse float function. That parse float function, by the way, for those of you who don't know, it's just built into JavaScript. So now I've dried this up, and I've also added that parsing thing that I forgot to add, and now we can be a lot more descriptive here, and we can say floats from slider, slider A, and floats from slider, slider B, and hopefully now things are looking a little bit better. Hooray, JavaScript can do basic math. Look at that. 8 plus 3 is probably 11. So the reason I went down that little tangent was A, to have a little dig at JavaScript, because everyone loves to do that, but B, to highlight that even though we're being very declarative and very kind of abstract and building up this kind of stream, this chain of operations, we're still in JavaScript. This is, if you like, an internal DSL, an internal domain-specific language, but we're still in JavaScript, and that means I can use all of the good practices that I would normally use when writing JavaScript code when I'm writing this kind of code. So I saw some duplication, and I said, you know what, let me extract out a little helper function to remove that duplication. So just because we're doing this kind of more declarative style of programming doesn't mean that we have to stop using the good practices that we can use when we're doing standard kind of imperative programming. Okay, so we now have this combined stream that has, in fact, the combined values, A plus B. So the last thing we want to do is assign this guy. And we want to assign it, oops, I misspelled combined. And we want to assign it to the label A, or not label A, summed label, the text field thereof. And if we did things correctly, hooray, we can add 2 numbers together, and we've got our output here. Questions so far about either the example or the code as it stands right now?
I noticed that
It's a very good question, and that's actually the next thing I'm going to get to. I'm going to get to that in just a sec, but if there's other questions before I answer that question, I will take them. Is this making sense so far? You guys are all super stoked? Yes?
So if you visualize the top, you don't have a parameter, so you can visualize the combined without parameter, why do you
One of them has a string and one of them doesn't. Is that your question? So that's just a nicety that I added so that I can, when we create the visualization, it has a title. It's just the title of these. So I could go back here and say floats A, and now it's just the title of the thing. So just a nicety to help kind of figure things out. Any other questions? All right, so the gentleman over here made the very good point that when we first load this up, there aren't any values. And when I first moved slider A up here, you can see that values are flowing through the stream A, but no values are flowing through stream B. And what that means is we don't have any combined values. And if you think about it, this makes perfect sense because the combined stream is by definition the current value of stream A and stream B. As you can see, stream B has no current value, so Bacon has nothing that it can do, so it doesn't do anything. It just sits there kind of twiddling its thumbs waiting for there to be a value. As soon as a value shows up on that second stream, now we're off to the races. We have a value in both of our input streams, so we can always create the combined stream. And now whenever either of these two change, we're able to update the computed value and everything's good. So that's why this is happening, but how do we stop that from happening? How do we make it so that when we first load this program, we get values? Yes?
Can we initialize this stream, in this case, with some initial value?
Yes, we can, and that's what we're about to do. Can you initialize the stream with an initial value? Yes, you can, and this is how you do it. Over here, we've got our shared function. It's lucky that we pulled this code out because we're going to make some more changes, and look, we can only do it in one place now. That's nice. So we can say toProperty, and we're going to give Bacon the initial property that we want. So now this is the flip side of the general nature of Bacon and of this FRP solution. What I would like is for Bacon to just know how to get this initial property. It's the initial value of the slider, like why do I have to tell it? The answer is Bacon doesn't really know anything about jQuery. It doesn't know really that much about what we're trying to do, so it doesn't know that in order to get the initial value it should call slider. In fact, the point that you're calling this toProperty method, it has no idea where this stream came from. It's a general stream of values. So this is really helpful because it means we can use the same tools for any stream, but the downside is because it's so generic, sometimes we have to give it a helping hand and tell it how to turn something into a property. And in this case, to turn it into a property, all we do is call slider.toVal, and that's going to get the current value of the slider. And so hopefully, what that's going to mean is now, that's great. We have current values for when we load, and that means that straight away we can create this combined value, and straight away we can populate all of our output fields. So it has the effect of essentially kind of bootstrapping the program and setting the initial value of things. So the first flow of things through the stream starts, and now if we change any of these values, the appropriate thing happens. So questions about that so far? Yes?
If you were to, for example, set the summer to fire the next tick, which is when it gets assigned, so the first two events are fired first, is it going to have to wait for another event to fire, or will it be based off of the current value of the slider?
So I'm going to paraphrase your question to say, like, what happens if the stream is changed after things have started happening? Honestly, I don't know. And part of the reason I don't know is because the general practice you have with this FRP approach is you build the machine before anything's happened, and then you kind of press go and you walk away. So you build all of the streams and the relationships between these streams up front, and then you just kind of let the thing take off. So you don't tend to modify modify things inside of the streams and build streams at the same time. I kind of think of it as it's kind of like compile time versus runtime. I'm kind of building the machine and then I press go and it runs. Yeah. Other questions? Yes?
So, from what you're saying, there's no way to turn off the stream?
Is there a way to turn off the stream? Yes, there is, in fact. So a stream can turn itself off. So let's say we have a stream that represents the result from a network call. Once that result comes in, we're never going to get a second result. So at that point, the stream will signal its consumers, like the downstream things, to say, we're done now. So that's one way. The stream can say, I have no more values, I am complete. And you can also, I believe, tell a stream to stop producing events. I'm not actually sure how you do that, but I'm pretty sure you can. Other questions? Yes?
Does the stream have the ability to maintain its history? Can you go back and play the events of the stream?
So does a stream have all of its history in it? No, it does not. A stream has the current value. You could do some tricks to get the previous history, but it only can tell you what its current value is. And I get this question a lot, and I think it's because we're thinking imperatively. So I would guess maybe that you're thinking like, what if I want to do some kind of look back in time and do some stuff based on the previous state of things? One of the really big ideas with functional reactive programming is not to think about state and not manage state yourself and just set up the streams to say, do all of this stuff for me. Like you define the computation, but you don't have to do that bookkeeping of keeping track of these things. So generally you don't need to do that kind of stuff. And if you do, you can do some tricks with streams to kind of offset them so that you can get a previous value. But you tend to not do that at kind of runtime, you do it at kind of compile time, as you will. Yes? Can you have an async function to do a transformation?
So like there's some are async.
Sure, sure. I actually don't think you can. You would represent an asynchronous function with a stream itself. So if you think about if you think about promises, for example, if you look at it a certain way, a stream is a more general version of a promise. A promise will always return one value at some point or an error. A stream will return one or more values or an error at some point in the future. So in the same way that we can model asynchronous operations by creating something that returns a promise, in FRP land, we model things that are asynchronous by creating something that returns a stream. Now this gets really weird when you start to create streams that produce streams of streams. And that's actually how you model those kind of problems. So this is going off on a little bit of a tangent, but I think a lot of us have had that experience of working with arrays and an array of arrays, right? So you have an array, and inside of it you have some other arrays. You can think of streams as being arrays where things are coming out of it not all at once. And just like you can map over an array, you can map over a stream. Just like you can flatten an array and say, like, the values are the values, just turn it into one big line of all of the values, you can do the same thing with a stream and create turn a stream of streams into a single stream of values. And that's, I don't think I have time to go into the details of how it works, but that's how you model things like asynchronous operations, is you map a value into a stream of the result values, and then you flatten that to get the final output that you want. Which is a little bit mind-exploding if you haven't done it a few times, but after a while it starts to feel similar to working with arrays of arrays, for example. Okay, I'm going to move on. So the key thing that I want to get across with these examples is this declarative nature and the fact that I'm not maintaining state at all. So if you look at, if you stripped out this, well, let's actually do it. Let's say, let's not do it because it's boring to watch me edit code, but if you took out the intermediary variables and just used assignment, just change these operations together, like you would maybe with jQuery, there's actually no state being managed in this program at all, apart from kind of keeping hold of these little objects up here which never change. If you think about how you would model this problem of adding these two values together in a typical imperative way, you would probably say, okay, slider A moved, so remember what the last value of slider A is and put it over here, and then go and find the last value of slider B, which I've stored somewhere else, and then add them together. And then when slider B moves, you say, okay, well, I've got to use the new value of slider B, but I've got to get the old value of slider A and add these together. You're doing a bunch of tedious bookkeeping to manage this mutable state inside of your program. And that isn't actually what you care about, right? Really, all you care about is, I want a value that represents these two values added up together. And all of the rest of that stuff of like, what was the previous value over here? Let me make sure that I get the new value here, but the old value there, and combine them together. It's all just tedious stuff that the computer makes us do. It's not actually the heart of our program. The big win, I think, with FRP is it comes down to just this. I just say, declaratively, this stream is this plus this, and Bacon does all that stuff for me. So I don't have to manage state anymore in my programs. I just tell the program the very high-level business concepts. This value is this value plus the other value, and I let the computer do all the tedious plumbing and bookkeeping that we normally have to do ourselves. And this is a huge win. This lifts the level of abstraction for us as developers and lets us focus on solving the problem that we care about rather than solving the tedious mechanics of computer programs and variables and state. So this is the reason why I find this model so exciting. Other questions about this code before I move on, because I'm going to kind of go back to the theory a little bit. Yes? Can you convert generators to streams? I imagine you can. I've never done it myself. I'm sure you can, because it's just in the same way as generators and promises play nicely together. I think generators and streams would play nicely together. I'm not sure if there's something out there today that would do it for you. But if you kind of lift the cover on this thing, underneath it, it's just callbacks and JavaScript. This is like Bacon, the way it works, it's just a JavaScript library. It's not got any superpowers that we don't have as programmers. So you could certainly write something that converts generators or makes streams and generators play nicely together. Other questions? Okay. Oh, yes. Yeah. Yeah. So how do you compose large systems of this thing is essentially the question, right? So I would say you can use the similar techniques that we use when we're building object-oriented systems. We encapsulate big complex pieces of machinery behind a simpler interface. And we break our problem up into small modules. And then at a high level, we kind of get those modules to work together. And then at an even higher level, so we kind of like have layers of complexity in our program. You can do the exact same thing with functions and streams. So just like here, I could have declared this as an anonymous function while I was building a stream. Instead, I pulled it out into a concept, the concept of a summer. I can do the exact same thing with a stream. I can have a function, and I can say, hey, function, please give me the stream that represents these two things added together. Under the covers internally, it's going to be doing a bunch of stuff and doing some complex things. But I have the ability now to switch contexts when I'm programming. When I'm programming at a high level, I can just think about this function which gives me a stream, and I don't have to worry about the internals. When I'm programming at a low level, I can really focus on how that function is producing that stream, but I don't need to care about how it's used. So, and I would argue, because this model is so, at its core, it's very simple. It's like this idea of slotting pipes together and functions that take things and return things. And because it's simple, it's very composable. I like to think of it as it's kind of like Lego, right? There's a few types of Lego, and you just assemble them into whatever you want. And the Lego doesn't really care what you build. It's just there to be a tool. It's the same idea with these streams. You can compose them in interesting ways, and you can write things that work with streams that don't really understand what the stream's values are. So I think it actually really lends itself to composability in like large-scale systems. Okay. Oh, yes.
So this part makes sense. I guess what I'm trying to figure out is if you want to have a button that you click on and it shows you the log that combines some value.
Yeah, so how do I get like a button that when I click on it, it would show me the current value? So I would have a stream of click events for that button, and I would combine that with the combined stream, and when they both happen, I produce a value, or I take some action. So everything is a stream. Every user interaction is a stream. Every network call coming back is a stream. Every network call going out is a stream. Now you can put boundaries around this. You could say just this part of my program is done in an FRP style and the rest I'm going to just do in some other way. But you just model everything as a stream. And you use the same, again, kind of, I keep on saying this, but you use the same general purpose tools for all of your streams. So because you have these, a nice toolbox of ways to work with these streams, and everything is modeled as a stream, it means you can solve a lot of problems in a very general way. Other questions? Yes?
Is there possibly a website that will kind of give you like the stream to get data from backend?
Yes. Yeah, so if you want to like plumb this up with WebSockets, absolutely. I don't know if there's something that exists today, but it's trivial to build custom streams. It's very, very straightforward to do this. And again, once you've got that stream, it's just a stream and all the tools you have work. So yeah, it's very straightforward to do that, actually. It's a really good fit for that kind of asynchronous networky stuff. Yeah?
What data structure or database do you use to record streams you can play back?
So how would you record these and play them back? In whatever tool you want, right? Like, so in the same way that I'm assigning the output of the stream to the UI, I could assign the output of that stream to Mongo or MySQL or whatever data store I want, and then at that point they're just values. There isn't something that works nicely, like that's built custom for Bacon, as far as I know. But if I did want to store these and work on them in the future, I'd stream them into some sink, some database, and then when I wanted to work on them in the future, I'd stream them back out. And again, because I can just represent input and output as streams, I can use the same tools for all of that. Yes?
What sort of integration is there with other frameworks like Angular and data binding?
Yeah, so what integration is there with other frameworks? There's a few kind of libraries out there that build on top of Bacon. So the thing I didn't say is Bacon isn't the only option here. There's a very well-established JavaScript library called Rx.js that's built by the guys at Microsoft who actually did this an amazing job with Rx in general. There's server-side versions, there's a JavaScript port. Very, very awesome work that they did. I don't generally say that about Microsoft, but I will in this case. I've totally forgotten your question. Sorry, I went off on a tangent. What was your question?
Integration with other frameworks.
Integration with other frameworks, yeah. So there is some stuff that builds on top of Bacon. So there's a thing called Bacon jQuery that makes it a little bit easier to work with jQuery. There's examples out there. If you're familiar with to-do MVC, there's a to-do MVC example that binds, that kind of uses React and Bacon together. They're actually quite a good fit. Bacon and Backbone tend to play together quite nicely. There's nothing that I'm aware of that works with Angular's data binding. Essentially, they're both doing the same thing. Angular's data binding, or like Ember's computed properties, you could kind of think of them as versions of this stream. The difference is they're just for Angular, or they're just for Ember. This is a general purpose solution. Okay, I'm going to move on. I'm going to go back to a little bit of theory. So I started by talking about this big difference that I see between FRP and regular programming. And it's this difference between snapshots in time and managing state yourself versus streams where you upfront declare the relationship between these values and it just works. You don't have to think about the fact that things are changing over time because you've said how to relate these things together. I want to go from those kind of really applied examples of the UI to a very general idea. Here's a variable called A. Its current value is 12. And at this point here, I have said to my program, hey computer, I want a variable B which represents A plus 10. And at the point in time when I evaluate this line in my code, yes, B equals A plus 10. If a moment later I change the value of A, B does not equal A plus 10. My code is lying to me. I said like a line previously, B equals A plus 10, and now that is no longer the case. As programmers, this feels like it makes sense. If you showed this to someone who doesn't program, they would be very confused. Like, why does it say B equals A plus 10 there? It doesn't equal A plus 10 anymore. if you were using Excel, you wouldn't think about this. If you changed A, B would change to keep up, right? That's because Excel uses this same reactive model of programming. As humans, we actually feel a lot better declaratively saying B is A plus 10. As programmers, we've essentially got Stockholm syndrome. We think it's okay for us to have to keep track of this stuff ourselves. We think it's okay for oh, well, A changed. Of course I have to change B myself, right? Like, well, no, why do I have to do that? The computer knows I want A to be, or B to be A plus 10. Why do I have to do the work, computer? It's not fair. So, here's a better way. I'm saying the exact same thing. A is a value, currently 12. B is A plus 10. And then I change A, and guess what? B still equals A plus 10. I've lifted the level of abstraction. I don't have to think about, oh, is it going to be up to date anymore? That thing changed. What happens if someone over there changes it? I need to make sure that I know every time anyone changes any of my things. The only reason I care about that is because the computer's not doing the work for me. This FRP approach lifts the level of abstraction. I get the computer to do the work, and I just have to think about the business rules that I'm building. B is A plus 10. So that's what I think is so exciting about this idea. As I kind of hinted at, this isn't just about UI development at all. There's some other really interesting aspects of FRP. It has a really nice way of modeling time directly. So if you think about it, these streams represent the state of something at a point in time. You can actually have a stream that represents time itself. And you can combine that stream with other streams. So that, let's say you have a stream that represents time itself, and you say, I want to throttle that stream so I only get a new value, a new marble on that diagram every 10 milliseconds. What I have now is a timer that fires every 10 milliseconds with the current time. So I can model time directly, and then I can use, again, these same general purpose tools to work with time directly, which is pretty mind-blowing if you ask me. As I talked about, it's a really good fit with any asynchronous operations. So network calls, or dealing with anything that's not going to respond immediately, which is pretty much everything in JavaScript. This works really nicely because you can model the result of an asynchronous operation as a stream. It's like promises, but it's more general purpose. And this is not about UI. The examples I gave were UI examples. I was using jQuery because it's very tangible and we can see what's happening. But almost all of the tools that we use with Bacon are general purpose. They're not welded to jQuery. I could use them for node programming. I could use them for UI programming. I can use them for any kind of programming where things are changing over time and where there's asynchronous operations. So it's a very general purpose tool. I took a bunch of questions. I've got time for some more questions. And if I don't get a chance to answer your question now, come and find me and talk to me. As hopefully you can tell, I'm kind of into this stuff. And I'd love to debate and have you tell me why it's all nonsense and all that stuff. So yeah, any more questions? Yes?
So you mentioned RxJS. What are the major differences between it and Bacon?
What's the difference between Rx and Bacon? Rx is probably more popular. Bacon was built by someone who didn't quite like the model that Rx uses. They're very similar. I actually don't know why I picked to learn Bacon rather than Rx. Yeah, I couldn't actually tell you. They're pretty similar. I'd say that Rx has the advantage of being a lot more, probably more widely used. There's more general purpose documentation. The way it models things is a bit more clunky. It's a bit closer to the academic side of things. So it doesn't have some of the tools that let you think about it in a kind of a more casual way, I guess. That'd be one thing I could say. And also, if you go to the Bacon website, there's a section where he talks about why he built it. I can't remember what he says. Other questions? Okay, thanks guys.